So thank you for the introduction and thank you for the invitation. We're really excited to be with all of you guys tonight. We're just going to talk about how tiny forests fit into landscape architecture. And Jasmine, tiny forests, mini forests, microforests, pocket forests, little forests, I've heard. So the name, it kind of evolves from place to place, but I think mostly it refers to the same idea. So I just maybe want to highlight here that we have our email addresses that we can share with all of you at the end of the talk. And Mark and Heather, do you want to add anything to the introduction that that Jasmine provided? I can hand it to you if you do.
No, just to say we're really happy to be here. So thank you.
Yeah.
All right, thank you. So tonight we want to talk about what is the Miyawaki method for planting tiny forests, who is planting these forests, where, why, when, what are some variations of the method, why has this method gained popularity, and how are they planted, and Mark will talk about a design case study. So what is the Miyawaki method that we use for planting tiny forests? Basically, it's a way to restore native forests, even in small and highly degraded areas, in anywhere where the climate supports forest vegetation. And so this method rests on a few key variables. Species composition, we're planting the native climax forest species. And then we're planting not only the tall canopy trees, but also the understory trees and shrubs to make up the layers of a natural forest. And then since we're often starting on ground that's compacted and missing its topsoil, we need to loosen up the soil and add organic material to start to approximate the loose living soil that you'd find in a mature forest. We're planting at a density of 3 per square meter and 3 plants per square meter. And then we're planting when the trees are still really young, only a couple of years old, and they're, generally less than a meter tall. So they're not making their own shade or litter yet. So we need to protect the soil with a thick layer of mulch that we put on right after the planting. And that holds the weeds down and holds some moisture in the soil while that little forest is getting started. The picture on the right is inside a mini forest that's in the state of Indiana in the US. And this picture was taken when that mini forest was only 5 or 6 years old. So I mentioned climax forest species, and those are the shade-tolerant plants that grow in at the end of the period of natural ecological succession. So this picture here is a timeline, and it starts on the left. It's about 100 or several hundred years, depending on what forest community you're talking about on the planet. But it starts on the left with bare ground. And then I think if you can picture any sort of vacant lot, and what we often see this first stage of succession where that ground gets covered with small, fast-growing plants that take advantage of all of that light and space. They make a lot of seeds, they spread out. I'm thinking dandelions, little grasses, clovers. And over time, you get bigger plants coming and colonizing the area. Eventually, you get some shrubs and then tall, fast-growing pioneer trees like poplars and pines. And all of these different waves of vegetation are actually changing the conditions of the site. So when we started with hard sun-baked ground, we're now having a space that has a lot of organic material. The roots have loosened up the soil. They've dropped their litter. The plants have dropped their litter. They're holding moisture in the site a lot more than that bare ground. And then they're also creating shade. So now we have the conditions for a different community of plant species to come in. And so we get to this later stage, the climax stage, where you have shade tolerant plants that germinate in that nice shade that's been created. And then they grow up and they take over the canopy, and they're creating a really full shade there. And so all of those earlier species that needed light to grow can't grow there anymore except along the edges. And so and so now you have sort of a self-perpetuating climax forest community that can remain in that spot for centuries or even millennia in the absence of a disturbance. And so what the Miyawaki method does is it takes a look at this timeline and just jumps ahead to the end and plants those climax species directly, but also recognizing all of the work that those earlier successional species did to improve the soil to make it thicker, more organic matter, and looser. And so then we do that step ourselves. So that's sort of the soil preparation step is to make the soil closer to what it would be in that climax forest stage. So Elgene Box, this is a quote from Elgene Box, Professor Elgene Box, who is with the University of Georgia. He's retired now. He is a former colleague of Professor Miyawaki, who developed the method. He said, the logic of Miyawaki's method is to create a permanent canopy of climax tree species directly without going through the successional stages. This creates a more humid, shady forest microclimate as quickly as possible. And the picture you see here is from a 5-year-old mini forest in Paris. And you can see that even after just a few years, those plants that were planted close together are leafing out, they're touching each other, and they're creating a canopy, which is creating a lot of shade. And so this is something that people really like about the Miyawaki method, is that after just about 2 or 3 years of weeding and watering that system, it gets to the point of being self-sustaining, because it can be shading out the weeds and holding moisture, so it no longer needs to be weeded and watered. And in fact, you can just let it grow and develop on its own at that point. So a critical first step in doing the Miyawaki method is to figure out what that climax community would be for the site that you're going to plant. And the way that Miyawaki referred to this was as potential natural vegetation. And so this can be kind of complex because our landscapes are so thoroughly transformed. But a way to orient yourself ecologically is to look at a map like this, which shows the ecoregions of your area. This is the state of Minnesota, and it shows the ecoregions which have their own characteristics based on the climate and soils and topography, and then their associated plant community. And so the picture on the left there is a state forester in Minnesota who helped us with our project in St. Paul, Minnesota. And she is having a look at the soil. And once she was able to get a sense for what that soil type is, then she could cross-check it with her native plant community map and give us an idea of what the native plant community would be for that site if it had never become a lawn in the first place. So so I'm going to shift gears here. So that was sort of an explanation of what the Miyawaki method is in technical terms. And now I want to talk about who is planting mini forests, where, and why. And the pictures here, so it all started with Professor Akira Miyawaki, who is a Japanese botanist who developed the method and started planting tiny forests started planting using that method in about 1971. So he's pictured second to the left there. And over the course of his 50-year career, he planted in nearly 3,000 places, mainly in Japan, but in about 17 other countries around the world. And one of the other countries he planted in was India. In 2009, Miyawaki's team planted a little forest at a car factory in Bangalore, India. And one of the people who volunteered to help with that planting was an engineer named Shubhendu Sharma, and he is pictured there on the left. And that day, I think, really changed Shubhendu's life, because he had been working as an automobile engineer, but he became so interested in this method and its potential that he learned everything he could about it. He left his job and started a forest planting company. And he started also sharing what he was learning, teaching people around India and around the world about this approach. And so one of the people that Shubhendu taught was Dan Bleishrot, who's pictured there on the right. He is in the Netherlands, and Shubhendu helped Dan plant his first forest in 2015. And since then, Dan has planted hundreds of forests around the Netherlands, and also has been teaching new forest makers throughout Europe. And so this map gives you a sense for the spread of the Miyawaki method. You can see that it's really taken hold on every continent. And these are just estimated numbers. It's actually a little bit hard to know how many mini forests there are in the world, because, for instance, our project in St. Paul, I don't think anybody knows about that just by searching the web. And so this graph, or this table here, is kind of a snapshot, and it's showing some of the major projects around the world, starting with Miyawaki and his partners, nearly 3,000 places around the world, starting in 1917, and then getting a hold in India. I think India has planted more than that number, 138. They've been planting many. They've been planting many since 2011 in India and elsewhere in the world. So you can see then how this is spreading to other countries. Sugi, there in the middle, is an organization that is helping to finance mini forest projects around the world. And just since 2019, they have supported 184 projects in 24 countries. So what's missing from this table is all of the tiny projects, like the one we did in St. Paul, other groups that have planted, a few mini forests in the past few years, or maybe several dozen. But here, these are just the projects that have planted many, in the hundreds. So I'm just going to show you a few pictures. This is a 5-year-old mini forest that's in Paris, France. It's 5 years old at the time this picture was taken. This is a mini forest in Japan, and the mini forest is basically planted in strips on either side of this path. And this picture was taken when that planting was about 14 years old. And then here is another Miyawaki method forest also in Japan, and this one is a few decades old. So that gives you a sense of what these projects look like as they grow over time. So I'm going to pass the mic now to Heather.
Thanks. Yeah, so why has this method gained popularity over the last decade? What's drawn people to plant these little forests around the globe? And within this era of climate change, human alienation from each other and from nature, and of course, ecological collapse, planting forests promises hope, action, and reconnection.
to move the slide.
Oh yeah, next slide. Sorry, yeah, I'll let you know. Yeah. Okay, so we're gonna just do a little exercise that Hannah said that she often does, that I thought was pretty neat. So let's just sit on this image for a moment. This is a photo I took while in Muskoka, Ontario, doing field work. Okay, so just imagine you're there. It's quieter here, and if we sink into this space, we might find our attention drawn to the movement of a millipede along the fallen log by our feet. We might hear some birds call in the distance, or become aware of the buzz of a bumblebee nearby. The air is cooler here. It is hot beyond the forest, but here the air is comfortable and the soil is spongy. If you take a moment to peel back a layer of needles and leaves, you would notice rich, dark brown soil laden with mycelial threads and still damp from the rain that passed by several days earlier. This is why I plant forests and why so many others do too. And I highly recommend you give yourself this gift of spending some time in the woods. Next slide. So the concept of biocultural diversity provides a more complex and integrated perspective on the diversity of life, as diversity is both nature and culture. Miyawaki forests around the world are most often planted by communities, school groups, or during staff engagement days. By taking time to restore our cultural spaces with ecological biodiversity, we do reconnect to place. By spending time with plants, we learn about other species and we pay attention to their growth and health. Countless folks involved in restoration plantings like these have shared with us the joy and gratitude they have felt by nurturing life. This process can be deeply healing, as is the case with communities that have had the opportunity to plant medicinal and sacred species within these little forests. Next slide. Due to the highly dense planting arrangement, tiny forests inadvertently become spaces for species other than humans. I have a mini forest in my backyard, and after just 2 growing seasons, it's become super challenging to enter into that space. The biodiversity of plants boosts the opportunity to provide food for specialist and host-specific insects. With a diversity of insects, birds and other creatures may find a place to feed and breed. Without constant foot traffic leading to soil compaction, and where leaves are left to biodegrade, tiny forests offer healthy soils for fungi, slime molds, which are pictured in the top right there, and soil organisms to thrive, with like that little springtail who's feeding on the slime mold, which of course leads to healthier soil and plants. The Miyawaki method is about planting a community of species. So this is important. It is about planting a forest, not just trees. At the root of this, we may begin to recognize that all species have equal right to be here on this planet, not just humans. It's totally equal. This is why I love this method. Next slide. Right, furthermore, by planting a diversity of plant species, there is a better likelihood of the planted forest surviving drought, floods, and extreme weather events. By planting a mix of species that are adapted to current and or predicted future climate conditions, we offer the forest a better chance of surviving unpredictable climate variability. Research out of Florida, USA finds that planting clusters of trees in lieu of a single one lends to less hurricane wind-induced tree failures. And this is because tree roots develop a lattice throughout the clustered planting, which is more stable than isolated tree roots. Although you have to bear in mind that you have to plant that tree and let those roots out so that it can be quite stable. And then just before we jump from this, the image at the very top, that's just the variation of current and predicted species range of sugar maple. So you can see right in the dark blue, that's where it currently resides. And then in the light blue, with a more extreme climate scenario, we're seeing it fully entering into the boreal forest. So if we can help that mobility a bit, it might hedge our bets against potential future climate scenarios. All right, next slide. Okay, since the Miyawaki method has expanded throughout the globe and practiced by various groups, some variation to the methodology has inadvertently arisen. So let's take a look at a few. This is just very quickly going through some of this. Yeah, starting with planting area size. How small is too small? This question often comes up. When Miyawaki was first planting these forests, they were typically larger than most planted today. Some say the minimum threshold is 100 square meters. I've read that the forest should be no narrower than 4 meters. And at the same time, there are some groups that are planting as small as 6 square meters. So it's quite diverse. Next slide. Another matter that's come up the method recommends a 1 meter excavation, followed by adding amendments to improve soil retention, organics, and soil structure, which is what Hannah was talking about, like mimicking that forest soil. There are, however, a number of organizations that are either only excavating to 50 centimeters or merely smothering existing vegetation with cardboard, which you can see on the left, before adding those amendments such as compost, aged manure, and mulch on top. Those who have opted against excavation do so based on soil ecology or because excavation is costly and energy intensive. And there's an international group of Miyawaki forest practitioners and academics who are intent on comparing forest growth and survival rates between these different kinds of methods, but it's just at the beginning of that research. Next slide. All right, these images are from, you can correct me here, Hannah, that these images are from Miyawaki's team, right? Was that with the Nippon planting?
Yeah.
Yeah.
It was Sengo Company that sent it to
Okay.
me, and he worked a lot with Sengo.
Okay. So as you know, they were involved in countless plantings, and the method recommends planting 60 centimeters on center, which averages to about 3 or 4 plants per square meter. And groups influenced by traditional forestry practices have been planting at much lower densities, such as 1 to 2 meters on center. However, if not planted dense enough, light and space is made available to unwanted plants that may seed into the forest. And these plants can overwhelm the trees and become a maintenance problem. And you're not capturing that, what Hannah was talking about earlier, about having that shaded soil to mimic a more climax forest community, even after just 2 years of growth. Next slide. And this density matter becomes an issue when mimicking forests with lower stem counts, such as semi-arid scrublands, as in Australia, depicted at the top here. The Miyawaki method is meant to mimic forest structure, which works best for temperate and tropical forests, seeing that in the middle and below. Next slide. Right, I've already alluded to many of the benefits and drawbacks, but I'm just going to throw you a few more. All right, next slide. All right, so how we engage the landscape here in North America is still very much inspired by historic Western European practices, such as the lawn and border plantings illustrated here at Versailles, France. Next slide. But of course, here in North America, we have taken the grandeur of Versailles and rubber stamped it at the residential scale. Next slide. So lawn with formal plantings contributes to landscape patterns like the lower left, which have often replaced previously forested landscapes as depicted in the top image. Perhaps there's a middle ground where human habitation occurs within forested landscapes by re-injecting forests into urban and peri-urban spaces. Next slide. Okay, so one of the potential drawbacks to planting forests in urban spaces is that we can inadvertently create an ecological sink. In landscape ecology, this term refers to a space where species are drawn in but unable to reproduce, thus draining the larger landscape of that species. Examples where we could create an ecological sink in the city would be by planting near windows, thus contributing to bird collisions, or by encouraging birds to nest where cats may predate. Looking at the larger landscape, however, these little forests placed in concrete dominated milieus may offer a resting spot for migratory birds and butterflies. This is the case with Toronto, Ontario, Canada, which is pictured here as the kind of big pink blob in the lower left image. Some migratory species require a space to replenish after flying over the Great Lakes. So you can see Lake Ontario there, while en route to the boreal forest further north. Now, Mark is going to speak to you about such a forest planting in Toronto's, on Toronto's waterfront. I'll pass it over to Mark.
All right, thank you, Heather. Thank you, Hannah. I think kind of the emphasis I want to make on what I want to tell you today is this difference between plant time and contractor time. And I think kind of the problem with the ecological crisis is that it seems plant time, which was what dominated life in the past, has now been taken over by contract time, which is kind of was pressing everything to go at speeds that outpace plants and biological systems. And how do we bring these things together? So if you look at the next slide, Hannah talked about the forced succession. And so we're in a hurry. And so most of the time we're choosing species at the end of the succession cycle, as you can see here. And I mean, that can save, a lot of time. Instead of starting from 0, you can skip 70 to 100 years ahead by choosing species from the top of the succession line. This is not specific to Miyawaki. I think if you're going with traditional, for example, ball and burlap tree planting, this is often where we're choosing our plants. So this is just kind of a starter. But if we look at the next slide, and we see kind of what, how many years does it take for a tree to grow? And they're grown in nurseries. And the word nursery, that's where you put your children for a few years, because children won't survive on their own until they get to be a certain age. And the same applies for trees. Starting at a seed, first, second, third, fourth, fifth, sixth years, they're vulnerable out in the public realm where they can be, damaged by dogs or people. And usually around this line, around 7 years, 8, 9, 10, that's maybe when it starts to be safe to put out and it can stand on its own. You can send your baby off to school and it'll be safe. And for us, that maybe the tree size at this stage would be between maybe 50 to 80 millimeters. After that, it starts to get maybe too old and it starts to have difficulties transplanting. So this is where we kind of are currently conventionally moving trees from nurseries to landscapes. Look at the next slide. But a contract works differently. This is a contractor schedule for a project I'm going to show you at the end of the presentation. But you see where the yellow kind of intersects, those 2 little green bars, that's where planting is inserted in this process. And you can see the contractors are very good at doing things fast, because often if they don't do it on time, they pay a penalty. So it's all about money and contracts and things done on time. They're good at concrete, asphalt, but usually not so good at planting. And here, the planting is quite early in the process. Normally, it's right at the end when there's no more sort of heavy construction happening. Here, it would have to be integrated earlier because it's a Miyawaki forest. It needed to be planted at the right time. And they did a great job at making sure the base conditions for that were in place early on so we could get planting done at the right time of the year. Look at the next slide. So if you look at nursery grown trees, kind of a conventional practice where we take them out and put them in a ball and burlap and move to the site, you see what happens here? The tree grows over a period of time, but look what's going on below the ground. This root structure, when it's growing in the field, it's a very complex web of roots that's integrated and adapted to its site specifically. And then we come along where we're ready to take those 7 or 8 years of growth and move it to another site by cutting off those roots and wrapping them into a ball. And this induces a lot of trauma to the tree. And if we look at the next slide, when this gets planted into a landscape, look at the top one, the tree recovery after transplant. The tree is trying to overcome this trauma and spends a lot of its energy just rebuilding its roots. And you can see on the canopy, it's not really growing that fast. What if we could somehow find a way to absorb that time, not in the nursery, but on the site, and recover that time period in the field on the site? So if you look, for example, the same time span, same number of years, a tree planted small will catch up to a tree planted big in a very short period of time. But there's a lot of other benefits to this. For example, the roots adapting in situ to the site. But if you look at the next slide, there's some kind of other benefits that are important as well. So if you look at the top example, where we have the ball and burlap forest, just some of the consequences or the impacts. So maybe a benefit is larger, less vulnerable trees at the start of the project. So your project, you open it, you cut the ribbon, it looks pretty finished because the trees are pretty big. That's a good thing, many people would say. But some of the other drawbacks, it's a limited stock at the time of planting. So even today, the contractor is proposing alternatives because what we specified is not available in the nursery. And you have no chance to do anything about it. You just have to take their alternatives. The time needed to overcome the shock for those roots to recover from their trauma. Maintenance to keep the understory niche from unwanted invasives. So because the niche, the subcanopy, the ground cover, the below the high canopy level, there's a lot of opportunities for invasives to take root. So it needs a lot of manual maintenance. Energy intensive, transporting and maintaining trees. Some of these trees come from very, very large distances away. In Canada, we get a lot of trees from Pennsylvania, which is a very, very far away. So that's very energy intensive from transporting them, planting them, and then maintaining them. And then when they fail, which is often the case when you plant burl and burlap trees, you have to replace them. Species diversity is limited. Nurseries reduce the risk by growing commercially popular trees. So if you want to plant something like a blue ash, which I'll talk about later, it's a very kind of specialized niche species. Nurseries are not going to carry that because it's too delicate and most people won't know what to do with it. So not available. And then the last kind of disadvantage of this is you have less control on tree sourcing and genetic stock. So it's becoming more important, this idea of provenance. Where do these trees come from genetically? And are they adapted to be able to continue procreate or reproducing into the future in the new locations? And sometimes trees and nurseries are clones, so they're not even sexually viable. So this is an issue that we need to address as well. So if we look at the Miyawaki method on the bottom, so maybe a drawback would be that the vulnerable tree, when young, it needs protection in areas with disturbance. So if you're planting these in cities, you need to protect them because when they're young, they're vulnerable. But some of the benefits, unlimited plant stock, you can customize, they're custom grown as needed by design. You can customize your plant palette. For example, in the project I'm going to tell you, we did cultivate from a seed source, blue ash, which most ash trees are under threat in North America. Blue ash is somewhat resistant to the emerald ash borer, but there's a lot of species that are dependent on ash. So if the ash trees are disappearing, so is that species. So the blue ash is kind of one chance to maybe try and hold on to those species that depend on ash. But those need to be contract grown and seed sourced to be able to work. Another advantage is that all niches are filled, so there's less maintenance requirements. All the ground cover, the mid canopy, and all the layers below the top canopy are filled, so there's no chance for weeds to get in. There's less energy intensive, reduced transportation and maintenance inputs because you're planting them when they're small. The species diversity is tailored at the start, part of the design process, and you can integrate seed collection to target species origin for greater genetic control. So we need to know where provenance is. We can control that right from the beginning. So if we go to the next one, I'm going to talk to you about a project where we did just this. It's in Toronto, and it's a very interesting site. You can see downtown Toronto on the upper right. What makes our site interesting? This is an industrial / post-industrial land, heavy industry, but factories are now turning into things like film studios. But it's an interesting transition. So if you look on the upper left, there's a piece of land there in the water. That's a human-made piece of land. And if we go to the next slide, that piece of land is very interesting because it has undergone natural succession in the old-fashioned kind of way. So I would say it's mid-succession right now. And we're right on the threshold between that system and very, very heavy, intense urban systems. And the park is straddling these two conditions. You go to the next slide. You can see what that means. But just before we do, this project was an interesting opportunity to introduce a new way of working. Normally, it's just a landscape architect, sometimes with an ecologist doing this. But we kind of have these super friends where we have three of us. And the third partner equally in this is the grower, the nursery, who does seed collection all the way through to maintenance. Because they coming on will tell you exactly what's available. They can collect the seeds that is for plants that are not available. And we have to get those plants started before the contractor is chosen. If we wait too long, the plants won't be ready for planting. And then we're going to get forced to take things we don't want. So it's too late to wait for this to be done in a normal contract process. We're insisting now that this happens at the design stage. Next slide. So this is just an overview and exo of the park. On the city side on the left is very intense human activity. There's an urban beach, there's ball and burlap trees, and there's lawns on the mounds. But on the right side, you can see where it's highlighted Miyawaki forest. That's where we're giving the space to the birds. It's not for people, it's a buffer to the noisy traffic and the dust of the industrial surroundings, but also a chance to build upon that natural succession across the road and embed it in the park as a stepping stone from lake and further into the city. If we look at the next slide, I think we're going to see a plan of how this was done. And it's a very complex planting plan, but quite simple to plant. We have 4 categories of planting. If you look at the next slide, I'll show you what those are. We have the canopy, sub-canopy, arborescent, and shrubs. We have these 4 categories. The previous planting plan just shows a distribution not specified of these 4 categories. So almost like nature just randomly seeding itself. This is also just randomly picking off a plant from, let's say, the subcanopy palette and putting it into that square. About 3 to 5 plants per square meter. We don't want 5 trees or 3 trees within the same square meter. We want a nice diversity of these 4 types. On this project in particular, there were mounds, so the upper areas are drier, the lower parts of the mounds are more moist. So we have also divided this into 2 categories for the upland and lowland species to tailor the species for those conditions. Now, this forest is designed on what would have grown here. We talk about the notion of potential natural vegetation. What would have grown here if it just had been on its own without any human management or any kind of disturbance? And if we look at the next slide, we kind of see a list of what that is. And so this is where we work with Heather and her office to identify what is this ecozone, or what kind of vegetation grows in this kind of niche condition. But there's also another thing that we wanted to tackle, this idea of climate change and climate adaptation. If we look at the next slide, we're trying to source seeds, and by doing a Miyawaki forest, you can select your seeds and target exactly the species genetically where you want. So Toronto is at the northern edge of the Carolinian forest zone, and Point Pelly is the most southerly point in Canada. It's also in the Carolinian forest zone. But the species here are adapted to a climate that's slightly warmer that we can anticipate will be the case for Toronto in the near future. So if we can source these trees genetically from this location and build communities that are similar to those that are growing here, we think there's a better chance that we'll be ready for a more sort of temperature stress-induced situation in the future. And the Miyawaki forest has allowed us to have this kind of control at the level of implementation, which is unique. Next slide. And this is what the forest looks like at Point Pelly. So we can anticipate in maybe 10 or 15 years, maybe a bit longer, this is the kind of forest we can anticipate at Leslie Lookout in Toronto. Now, almost finished here. I'm just going to show you some slides of the planting that we did at Leslie Lookout. This is last fall. I think it was in October, end of September, early October, where we planted. There's one shot, another view. The next slide is also planted, a photo from planting. That was taken last fall. Spring has finally arrived in Canada. And if we look at the next slides, we can see where we are now. So that forest is now starting its first season of growth in situ after planting. If we look at the next couple of slides. And this we really expect to see, because there's competition for light, but there's also cooperation at the root level. They protect each other. And we expect to see these trees produce a lot of new shoots within the near future. And what's also interesting is you see the ball and burlap trees, for example, here on the left, the Miyawaki on the right. We'll be able to see how they compare. It's like a rabbit and the hare, the tortoise and the hare kind of story, where one is slow but actually ends up winning. And we're going to kind of see that happening in our faces right in real time before our eyes. And then the next slide is just one more, I think, from Leslie Lookout. Oh no, this is the last slide. This is a view of Montreal. And just one comment I want to make is most of the forests that we see in cities are remnant forests. They're adapted or managed forests that were there before the city. And now it's been difficult to grow forests in urban conditions. And I think now with this approach, the Miyawaki method, the Miyawaki inspired method, I think we've figured out maybe a way to try to rebuild urban forests in a really impactful way that I think there's a great need for it at this time. So that's the end of our slide. That's the end of my slides. That's the end of our presentation. Jasmine, if you want to open up the floor to facilitate any questions, we'd be happy to answer anything you might have.